Good day, everyone. So our topic for this video is aldehyde. I am Dr. Irving R. Aprensive. So for our learning outcomes, which will serve as your guide in this video, we have describe the properties of aldehydes, determine the steps in writing a correct chemical name and formula of aldehydes, name and create chemical structures of aldehydes. So aldehydes are any of a class of organic compounds in which a carbon atom shares a double bond with an oxygen atom. So a single bond with a hydrogen atom and a single bond with another atom or group of atoms is designated as R in a general chemical formulas and structure diagrams. So a double bond between a carbon and oxygen is the characteristic of all aldehydes and is known as the carbonyl group. So there's also another carbonyl group which is the ketone. So these are the properties. Many aldehydes have pleasant odors, and in principle they are derived from alcohol by dehydrogenation or the removal of hydrogen, from which process came the name aldehyde. The polarity of the carbonyl group notably affects the physical properties of melting point and boiling point and dipole moment. So hydrocarbons, compounds consisting of only the elements hydrogen and carbon, are essentially nonpolar and thus have low melting and boiling point. However, the melting and boiling points of carbonyl containing compounds are considerably higher because of the presence of the carbonyl, thus making it a non-polar. Making them as polar. So, for example, butane that has 4 carbon, wherein its equivalent is propanol and acetone, all have the same molecular weight of 58, but the boiling point of hydrocarbon butane is 0 degrees Celsius, while those of propanol and acetone are 49 degrees Celsius and 56 degrees Celsius respectively. In this case, you can see here that even though the butane has more carbon, propanol has a lesser carbon, which is there are 3 carbon, no, but it has higher boiling point. Same as with that of acetone. So acetone is a ketone, which is also a carbonyl group. Propanol is an aldehyde. Acetone is a ketone. So acetone is composed only also of 3 carbon, but the boiling point is higher than the basic butane. So how do we name aldehyde? So the aldehyde is shown by changing the suffix "e", like for example, um, ethane to al. So ethane will become ethanol. Because the carbonyl group of an aldehyde can only be on the end of the parent chain, therefore must be carbon 1, and there's no need to use a number to locate it. So, meaning to say that the aldehyde group is always found on the other end, no? So it is always the first carbon. So since it is always in the first carbon, there's no need for us to write it the number because it is not changing. So same process, locate the longest carbon chain, and then the substituents are prefixed in alphabetical order along with numerals indicating their positions in the carbon chain. So for example, the CHO, the one on the right in carbon 1, is the aldehyde. Then you have to count from there since it is your carbon 1. So 1, 2, 3, 4. On the fourth carbon, there is methyl, and up to 5. So the longest chain is 5 carbon. So that is pentane. So pentane will be changed into pentanal, and then write the substituent as well as its carbon location. In this case, you have here 4 carbon on the fourth carbon. So let me look into that. So this is your first carbon. This is the longest chain. And then on the fourth carbon, you have here methyl. So it is 4-methyl. There are 5 carbon chain. So it is pentane, but since there's a presence of aldehyde, so therefore it is will be converted into from pentane to pentanal. So the name is 4-methyl pentanal. So these are the other examples. So the first three are basic. So we have here 1 carbon. So this is methanol, ethanol, 2 carbon, propanol, 3 carbon. So this came from the word methane, ethane, and propane. On this side is butanol with 1 substituent. So you may write here 1, 2, 3, and then 4. So that's why it is known as butanol. And then the substituent is found on the second carbon. So that's why it is 2-methyl butanol. These are some examples of uh, aldehydes. So you have here saturated aldehyde, and then aromatic aldehyde. Then so here you can see some common name and IUPAC name. So formaldehyde is a common name. So one thing that you can look into, same as with ether, there's ether at the last word. Here, what you can see here are uh, the word aldehyde is found as the last word, but it is not of composed of 2 words, but there's only 1 word. No, so this is 1 carbon. This is formaldehyde. Then acetaldehyde, 2 carbon. Then you also have here propionaldehyde, propanol. See, this is methanol. This is ethanol. This is butanol. This is malonyl aldehyde, nonanol, and then methional. Okay. On the other side is aromatic aldehyde composing of benzene. So you have here benzaldehyde, anisaldehyde, cinnamaldehyde, the one found in the cinnamon, and then vanillin, the one found on vanilla. Okay. So another one is unsaturated aldehyde. You have acrolein, cysteine, hexenal because there are double bonds. There are alkenes. Then you also have here decadienal. Sorry for that. So 2, 4. So 1, 2, 3, 4, 2, 4, and so on. And then another classification are the common saturated aldehydes found and dialdehydes found in foods. You have here purpural, glyoxal, and so on. So, yon. So these are some examples that we can be able to see in our food. So for the references, these are those. You may also check on this. Thank you so much for watching our this video lesson.